Welcome to D3.js Fundamentals. D3.js stands for Data-Driven Documents. It is a powerful JavaScript library that helps you create interactive data visualizations on the web. D3 allows you to manipulate documents based on data by binding information to DOM elements. Unlike other charting libraries that provide pre-built charts, D3 gives you complete creative freedom. It works with standard web technologies, including HTML, SVG, and CSS. The core capabilities of D3 include data binding to DOM elements, SVG manipulation and creation, smooth transitions and animations, plus the ability to build completely custom web visualizations from scratch. SVG stands for Scalable Vector Graphics, and it is fundamental to D3.js visualizations. SVG is perfect for D3 because it is scalable, meaning vector-based graphics that scale without any quality loss. SVG is programmable, giving you full DOM access with JavaScript manipulation capabilities. It is also standards-based, using XML format with CSS styling support. The example code shows how to create SVG elements using D3. You select an SVG container, append a circle element, then set attributes like CX for center X coordinate, CY for center Y coordinate, R for radius, and fill for the color. This method chaining approach is typical in D3 programming. Data binding is the core concept that makes D3 powerful. Data binding creates an association that links data arrays to DOM element selections. This binding is dynamic, meaning visual elements update automatically when data changes. The binding is also sticky, meaning data persists in the double_data_double_ property for ray selection later. The data binding process follows 4 key steps. First, select DOM elements using methods like selectAll. Second, join data using the .data method. Third, handle the enter, update, and exit patterns which manage elements. Finally, apply data-driven transformations to create your visualization. The example shows a basic data binding where D3.selectAll selects all paragraph elements and .data binds an array called myArray to those elements. D3 provides powerful selection methods for targeting DOM elements. The core selection, API, includes 2 main methods. D3.select returns the first matching element for a given selector. D3.selectAll returns all matching elements that match the selector. These methods use CSS-style selectors to find elements. The examples demonstrate both methods in action. D3.select with #mychart selects a single element with the ID of my chart. D3.selectAll with the selector P selects all paragraph elements in the document. These selection methods form the foundation for all D3 operations, as you must first select elements before you can manipulate them or bind data to them. The enter, update, exit pattern is D3.js core data join mechanism. This pattern handles 3 different states of data to element relationships. Enter represents data without DOM elements, meaning you need to create new elements for this data. Update represents existing elements that already have bound data, so you modify their attributes instead of creating new ones. Exit represents elements without corresponding data, meaning you should remove these elements from the DOM. The general update pattern code shows this in practice. First, you create a data join by selecting elements and binding data. Then you handle enter by appending new elements and merge them with existing ones. Finally, you handle exit by selecting and removing elements that no longer have corresponding data. This pattern ensures your visualization stays synchronized with your data changes. Scales are functions that map data values to visual properties like position, size, or color. D3 provides several scale types for different data situations. Linear scales map continuous input data to a continuous output range, perfect for numeric data like measurements or quantities. Ordinal scales map discrete categories to discrete outputs, ideal for categorical data like names or groups. Creating a scale involves defining both a domain and a range. The domain represents your input data values, while the range represents the output visual space. The example shows creating a linear scale where the domain goes from 0 to 100, representing your data range, and the range goes from 0 to 800, representing pixel positions. When you call xScale with a value of 50, it returns 400, which is the middle position in your visual range. D3 excels at creating SVG elements driven by data. Common SVG shapes include several key elements. Circles use CX and CY for center coordinates plus R for radius. Rectangles use X and Y for position along with width and height attributes. Lines use X1, Y1, X2, Y2 coordinates to define start and end points. The example demonstrates data-driven shape creation. The code selects all circle elements, binds a dataset, enters new data points, and appends circle elements. Each circle gets attributes set dynamically based on the data. The CX attribute uses xScale to convert data values to X positions. The CY attribute uses YScale to convert data values to Y positions. The radius R is set to a constant value of 5 pixels. This pattern allows you to create multiple shapes automatically from your dataset. Path generators create complex shapes and lines from data arrays. D3 provides several common path generators for different visualization needs. D3.line generates SVG paths for line charts by connecting data points with lines. D3.area creates filled areas between lines, perfect for area charts showing ranges or totals over time. D3.arc generates pie chart segments and circular visualizations. The line generator example shows the typical usage pattern. First, create a line generator function using D3.line. Then define X and Y accessor functions that use scales to convert your data coordinates. The X accessor uses xScale to convert date values to horizontal positions. The Y accessor uses YScale to convert numeric values to vertical positions. Finally, apply the line generator to a path element using the D attribute, passing in your data array. The generator automatically creates the SVG path string needed to draw the line. Transitions add smooth animations to D3 visualizations, making data changes more engaging and easier to follow. D3 provides several transition methods for controlling animations. The dot transition method initiates an animation sequence on selected elements. The dot duration method sets the animation length in milliseconds, controlling how long the animation takes. The dot delay method adds a delay before the animation starts, useful for staggered effects. The basic transition example shows how to animate a circle element. The code selects a circle, starts a transition, sets the duration to 1000 milliseconds, which is 1 second, then changes the fill color to red and the radius to 50 pixels. D3 automatically interpolates between the starting and ending values, creating smooth animation effects. Transitions work with most SVG attributes and CSS properties, allowing you to animate position, size, color, opacity, and many other visual properties. Advanced transitions provide more sophisticated animation control through easing functions, timing, and chaining techniques. Easing functions control animation pacing with mathematical curves, making animations feel more natural than linear timing. Popular easing functions include bounce, elastic, and cubic curves. Chain transitions allow sequential animations for complex effects, where one animation triggers the next automatically. Staggered delays create time-offset animations across multiple elements, perfect for revealing data progressively. The example demonstrates chain transitions with easing. The code starts with a circle element, applies a transition with 1000 millisecond duration, uses D3.easeBounce for a bouncing effect, moves the circle to X position 200, then chains a second transition. The second transition lasts 500 milliseconds and changes the radius to 30 pixels. This creates a compound animation where the circle first bounces to a new position, then smoothly changes size. D3 enables building complete interactive charts and custom visualizations from basic elements. Common chart types each use different approaches and SVG elements. Bar charts use rectangular bars with data-driven heights, where each bar represents a data value through its height or length. Line charts display connected points showing trends over time, perfect for time series data and continuous measurements. Scatter plots position points using two variables, revealing correlations and patterns in multidimensional data. The simple bar chart example shows the fundamental pattern for custom visualizations. The code selects all elements with class bar, binds the dataset, enters new data points, and appends rectangle elements. Each rectangle gets a class attribute set to bar for styling purposes. The X attribute uses X scale to position bars horizontally based on name values. The height attribute uses Y scale to set bar height based on data values. This pattern scales automatically to any number of data points in your dataset. Following best practices and effective debugging techniques are essential for successful D3 development. Performance optimization includes using CSS for styling instead of inline attributes and minimizing DOM updates by batching changes. Code organization involves writing modular functions with consistent naming conventions, making your code more maintainable and reusable. Data validation requires checking data types before binding to prevent runtime errors and unexpected behavior. Debugging techniques help identify and solve common issues quickly. Console.log data at each step to verify your data structure and transformations. Check browser developer tools for SVG rendering issues and JavaScript errors. Validate SVG attributes and values to ensure they are within expected ranges. Test with smaller datasets first before scaling up to production data sizes. These practices help you build robust, maintainable visualizations that perform well and are easy to debug when issues arise.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.